Great. Welcome back, everybody. Happy Tuesday. It's good to see everybody. Today, as promised, is a guest lecture from Dr. Chad Spensky, CEO and co-founder of a startup in Santa Barbara called Allthenticate. They're trying to market a technology called single device authentication, which we'll hear a little bit more about when Chad gets started. Just for some administrative information first, we know that there's a power outage on campus that's affecting the websites and the servers, and perhaps your ability to complete a certain project. Officially on the course policy, there's like a 6-hour window before we'll start considering extensions. And so if the power comes up before 8 p.m. Eastern, it's the normal deadline. If it goes much beyond that, then we'll start doing extensions for project 6. So with that out of the way then, so again, Dr. Chad Spensky will be giving us his perspectives on software engineering and telling us a little bit more about his startup and the role of software engineering in startup companies. Chad received his PhD from the University of California, Santa Barbara, a couple months ago, and he has taken the path that some PhD students take, which is to take part of their PhD research and try to bring it to market. So Chad is part of a brand new startup that's trying to market technology that was a good part of his PhD dissertation. And so in contrast to the last guest speaker that we had, who was from Google, Chad's bringing you a different perspective from startups instead. The final thing that I'll say, Chad, in addition to being an excellent researcher and a generally cool guy, he's also the purveyor of the world's best transcendent, life-changing barbecue brisket. With that, Dr. Spensky, please take it away.
Awesome. Thank you. Thank you. So I hope I am displaying slides full screen. We're looking good.
Yep, you're good.
Awesome. Yeah. So as Kevin said, I'm going to try and give you my take on software engineering. I've had a pretty interesting career path. So this talk is hopefully an embodiment of that and what that has taught me about software engineering. So through the eyes of a hacker, which is how I got started, an academic, an employee, and a CEO. So I've kind of got to see this from a bunch of different avenues. So first, my journey started back in middle school. I was an internet pirate, hacker, and tinkerer. So I would steal movies and games, kind of in the deepest realms of the world you could imagine. I definitely was way beyond Napster and that kind of stuff. I would hack my friends on the weekend. So I decided to go to college for computer science. I went to Pitt, got I got an honors degree in computer science and a degree in mathematics. Decided I actually liked this field, so went to get a PhD in it at the University of North Carolina, where I was pursuing a PhD in computer security. Dropped out to go get a job at MIT Lincoln Laboratory. This is actually where I met Kevin. I was research staff there for about 4 years, and then decided that I wanted to pursue this entrepreneurial route. Actually, it was one of the big motivators. We had the technology for my company was developed there. We patented it. So I came back to academia to kind of explore it and finish my doctorate out here at UCSB. During that time, I was a member of Shellphish, which is one of the top 10 hacking teams in the world. So competitive capture the flag competitions. And recently started my own company, which is now all I do all day, every day. So first, I want to define my definition of software engineering and what I think it means to do software engineering and not just write code. So in my mind, this is building software that's built to last, easy to share, amenable to collaboration, and has long-term maintenance in mind. So this is very different than just writing something over the weekend. You could write a hello world, but if you do it with proper software engineering, it could take you a day to write a solid hello world example. So started out, what did software engineering look for me in my hacker days? So this was actually me when I got into computer science. This is, you can kind of envision that I didn't do nice things on the internet, dressing like that and with that pose. And what I did back in those days, I was actually considered a site tech. What this meant is that I had root access on a bunch of illegal file servers. To do that, I had to learn SQL. I ran a database. I ran a website that had to do with all of these transactions. TCL was the language we used to program our bots. I taught myself some C, and then MIRC was the program I used. I learned those scripting languages. So these were all entirely self-taught. I didn't really have any instruction on them other than the 90s Google, or Yahoo at the time. So at that time in my life, there's definitely no software engineering. Had no clue what version control was. The only budget I had was that I could offer people movies and games. My hosting provider was my basement. I was the only developer. And when I would release it, it would literally just be, a tar file with all of the files in it and like a elite README file with some ASCII art explaining, how to install this thing and what commands to type. And that was it. That was like my intro to how to make software that other people were going to use. It went reasonably well. I raised, I was pretty high up in like the illegal world. I had a decent amount of respect for being a good programmer, but in reality, I was pretty garbage. The other stuff I did in high school, kind of self-teach myself computer science. I learned some VB.net. I had this idea where, I wanted my calendar to print every Sunday. Then I took this online, so taught myself how to interact with SMS and had like a Google Calendar type thing, and started a computer in my car, had like a YouTube type website I was working on, like a Sonos type thing I was working on. And then I got into Xbox modding so that all my friends could also play the illegal games. So this is kind of just so you know who I am and why my background in software engineering is weird and not traditional. At this point, I had no training, no classes on computer science. Tooling, actually wrote everything in Notepad and Pico and Vim. So there's definitely no IDEs, no fancy stuff. I didn't know what linting was. And I just had hard drives and partitions everywhere and would frequently have one of them die and just lose everything. So undergraduate career, I think that's where most of y'all are at this point. Like I said, I got a BS in computer science with honors, and sort of my take on universities and just like what I thought my undergraduate career did for me. I felt like it killed my creativity quite a bit as far as like engineering was concerned. I learned a lot of science. I learned how to pronounce MySQL and tickle that it wasn't MySQL and TCL. So that was cool to meet other computer scientists that, actually knew what the heck they were talking about. But sort of the vibe I got, like looking back at my undergraduate career, is that I stopped engineering things and didn't have these side projects where like, I wanted to build a complicated thing over a couple of years, a computer in my car or something like that. And I just focused on learning the techniques, learning what Pete was NP was all about, and, doing my homework. And after that, I would, I may have spelled epic wrong, but I think the greatest benefit for my undergrad was meeting people and making all of these cool connections and just learning from each other. So in my opinion, I did zero software engineering in my undergraduate career. I'm hoping that's not true of y'all, but that's kind of, what I'm here to sort of share my hindsight views with you today. So the tools that I used by the time I was at Pitt, we had Eclipse. We were a fully Java school. So at the time, Eclipse was like the only way to write Java, because otherwise, if you don't have autocomplete, it's just not going to work. Everything else I did in Notepad, because in my head, I was a hacker and like Notepad was elite. It showed that you knew everything about that programming language. Like I didn't need an IDE. And I actually learned how to use books and pencils with computer science, which up to that point, I never like drew out, the software architecture or any of that thing. It was just like, I don't know, we'll kludge it together. So that was a nice, valuable skill. Moving on, we go to graduate school round one. Ding, ding. I actually got into grad school for bioinformatics. I'd never done anything security related in my educational career at all. When I was touring, the security folks kind of, told me what their jobs were. And I realized that I probably was, an expert at that and didn't know it because I thought it was all illegal. So takes on graduate school round one. I think graduate school can be one of the most amazing experiences of your life if you find a project that you're working on that you really enjoy. This will be, probably the first time and one of the rare times where you can build something huge, where you can actually engineer a large thing over many years and do something great with it. Again, my take on grad school, there was a huge emphasis on like science and research, which were, in my opinion, kind of poorly defined, at least throughout my early days. I never really understood what that meant. And I took an internship when I was there where we had to use Git, which makes sense because we were doing software engineering. When I came back, I was like, I felt so stupid at my internship. Like, we have to teach this to graduate students. Like, there's no way we should be doctors in computer science and not know simple version control. So that didn't happen. So I definitely advocate for it. And my take again on graduate school, software engineering, I think should be a prerequisite. Like, you should first come in knowing how to build scalable, testable, verifiable, sort of solid software before you have any hope of doing science with software. I mean, it has to be sound and tested before you could ever trust your results. One bug in there could throw your results, off the deep end. Sort of the tooling I use there, and the reason I'm introducing you to the tooling at every phase in my career is because I think it's critical. Like, you need to have a good tool to do a good job, right? There's always like the analogy of a carpenter that doesn't have a hammer, right? If they have a really good hammer, they can do better work. If you give them a screwdriver, they're going to struggle to hammer in a nail. So at UNC, this is the first time in my life I really started to figure out how to write good software and good code. I used Dropbox to sync files with my home computer. So this let me actually collaborate with myself and two different computers. We used Subversion. Git was still kind of new on the market back then. The weird thing though is we had no shared repositories in our group. Never wrote a test script in my life, and there were bugs galore. Like, if you go look at my master's thesis, there's probably bugs. Like, the results might not be true just because I don't think I was writing the best code, and I had no way to really test it and verify, if I added a new feature, did it still work like it was supposed to? So going from there, I kind of got obsessed with this idea that became my startup, that I want to use smartphones to, get rid of passwords and keys and just have that identify me to the world. So I ended up taking a job at MIT Lincoln Laboratory. I was an associate staff in the cyber systems assessment group. This was effectively all offensive computing. So really playing in on the stuff that I learned as a kid and, applying it to good use for the Department of Defense. My take on Lincoln and, sort of MIT in general, that was like one of the best environments I've ever been in to be a software developer. Is insane. The projects were extremely interesting, like really huge, like multi-company projects within the DoD that would be, like $20 million programs that you're working on and you have to contribute to. Internally, we were small teams, so we would typically go from 2 to 20, but then our team would be, one of like 200 teams on these other programs. So it was awesome. Like, just the type of stuff we got to work on, the people you got to meet, and like the people you collaborated with that weren't software engineers. Like, you'd be hanging out with fighter pilots, but working on the same goal. The one really cool perk, I think, of being at a research lab is that prototypes don't have to be production quality. So when you get to the point where it works, you're done. Like, there's no code maintenance. There's no like, oh, we got to polish it and optimize it and make it faster. Like, no, you ship that off. That's for like the Raytheons and Lockheed Martins of the world. And this was like the first time in my life where I had to be a superb software engineer. Like, at that point, I was a good researcher. I was a good computer scientist. I was a good hacker. I was an absolute noob at software engineering. So I felt very, very ill prepared coming out of one of the top programs in the nation with a master's degree, which I think was weird. That's something, I did not expect to be that ill prepared to have a real world job in the field that, allegedly I'm very good at. So the tooling there, one of the biggest changes from academia to Lincoln Laboratory was just the amount of resources. Like, it broke my brain as like a young software developer to go there, and I asked for, I needed a couple of servers, and the reply to that email was, here's like 7 servers that have 24 cores each. I hope this is enough. Let me know if you need more. That's when I started using like GitHub Enterprise and really learning how to collaborate, write code that's easy to read, that my teammates could enjoy. Got introduced to tiled window managers. I can't even comprehend how people use computers without them now. Like, especially when you're doing development, to not have a hotkey to switch between, your terminal window and your IDE or your web browser. I can't even comprehend it after switching over. And the biggest thing I learned at Lincoln was that equipment makes a huge difference. So my PI there, day one, gave me this lecture explaining, the equation of productivity. And he's like, there's always a trade-off between time and money, right? He's like, in MIT, we have a lot of money. We don't have a lot of time. We don't have a lot of people. He's like, so anytime you could take money and trade it for time, do it. So, if your computer was too slow, like we were building the Linux kernel, I don't know, 10 times a day, there's no way we're going to do that on our laptop. So, spend the money, get the 32 core machine and do it right. The other thing I picked up at that point in my life was that you don't have to stick to one operating system. I've never used a single operating system since that point. I always have a Linux machine on one of my monitors and an OS X machine on the other. And the logic behind that is one of them is really pretty. That's the OS X one that I can, do presentations like this on, I can make slides on, but one of them is actually useful for development, and that's my Linux machine. So I think that's something worth noting. Like what I said, do the right tool for the job. Don't try to like run stuff in a VM and do all this craziness if it's really easy enough to just like do it on the proper OS natively. So the other interesting thing I got to do at Lincoln was top secret engineering. So we were doing, like classified work for the government. I won't tell you what, but the takeaway from doing this was that the internet is amazing. So to do classified work, you're in a closed space that for obvious reasons is not on the internet. So you have to literally take in like books. Like I had stacks of Python books and stuff that I would take into these places. And when you forget an API call, like you are flipping, page 278, like, oh, yeah, that's the argument, right? Like that's the type that I'm supposed to pass. And like, what the heck is Git archive? Like for us to take our Git repo from the unclassified world, but keep it in sync with the classified world, you can actually like tarball up your Git repo with Git archive and then go in there, and we would actually keep our Git repos in sync and have special branches. And my God, like if you think it's hard using GitHub and keeping your Git repos and everybody in sync, like this is like next level of doing, good software engineering and version control. And, you get one shot pretty much. Like you're gonna burn this DVD, that better be the right version. It better work. It better be tested, because once they clear that DVD, it could take another week to get another DVD in the closed space. The tooling here for, the top secret work, we had DVD burners, programming books, offline versions of the online docs. We'd literally, download the entire website of whatever, API reference we were looking at. And thinking on your feet, like there's no Stack Overflow. Programming without Stack Overflow was just wild. Like most of my code, I think, is a copy paste from Stack Overflow, but not in those days. And you have to like, it really tests if you know your language or if you're just good at Googling. So that was all wonderful. Like I said, I kind of had these entrepreneurial ambitions and kind of saw this like a now or never moment to come back and finish my doctorate. So I came back, I just finished my PhD in securing and analyzing embedded systems. So very low level, kind of right where the hardware meets the software. Take on graduate school round 2, a different school, different advisors. I had to work on some really, really cool, complicated problems that were all, pretty hacker related kind of things. If you look at the stuff we published, we found a bug like every Android phone on earth that was running Qualcomm or Huawei chips. It's like that kind of stuff was, pretty fascinating. But this time it really drove home to me how important repeatability is. Like, especially in academia, if you're doing science, you need to be able to reproduce science, right? I mean, if we couldn't reproduce any of Newton's physics experiments, I don't think he would be famous, right? But if you come up with a piece of software and you say your results are X, like you should get X every time. And even if you add a new feature, you should get X plus Y, right? You need to make sure that you're building correctly. My biggest take there is that experiments and continuous integration are not very different. And that, in fact, I don't think they're different at all. You're kind of setting up, your environment for, if you think like a chemistry experiment, all the things you need to produce that experiment, right? You're gonna have these different chemicals at these different levels. If you set up your CI properly, you will have that and it will be repeatable forever. You'll know what packages you need to install. It can be Dockerized so that I could send it to Kevin and he could repeat the same experiment. And this stuff like was never really taught or ingrained to me, but my God, is it like, it's necessary. It's been probably the biggest game changer in like me as a software engineer, is making all of the test cases for every software that I write. And now at my company, we do test-driven development. So no feature will ever get merged in if it doesn't have testing written out for it and the nice green little check mark. So, I mean, that was a big game changer. The other, thing I would recommend that I didn't do until later in my life was open source as much code as you can. And not because I'm an advocate that I think code should be free for everyone or that, it's your duty. It will make you a way better programmer. Like just the second you go to Git push, you're like, this looks, this is pretty garbage. I'm going to fix it. Like just knowing that others will see your code, you write way better code because you're putting your reputation out there. Future employers can look at it. Your friends can look at it. Random people across the world will look at it and then blast you for it. Like some of my open source projects early on, I would use like a globals.py and just got lit up on GitHub. People are like, this goes in init.py, you idiot, like move it. So you learn a lot as well, like working with open source. And then submodules, when you're working with Git, these are such a lifesaver. Like rather than having one huge repository, when you have complicated programs, you actually break it up into your submodules and then you track them all separately in Git. And what this does is it lets somebody go update the submodule, right? Add some critical bug fix and say you needed that in project 1, but not in project 2. So you can actually keep project 2 where it is. Project 1 goes out for the bug fix. And then, later down the road, you can merge them back in. I don't know how to explain it, but you submodules are sick. It helps so much while you're like testing something that you don't trash your entire repository. And it's just so quick to switch back and forth. So yeah, I mean, my biggest take on grad school is I think, like I said previously, software engineering is an absolute must. And I'm shocked that it's not pushed harder by the universities. That, they're doing the science, writing these papers, and it's more about the scientific result. But without a well-engineered piece of software, it's really, really hard because you'll get to this point where, a reviewer comes back and says, man, it'd be great if you could add this feature. And if you have this super kludgy code that doesn't have a good class hierarchy, you're done. Like that's going to take you months. Whereas if it was written very nicely and engineered in a good way, it's like no problem. You knock it out in a week, add the new feature, you're done, move on. So some of the tooling I used at UCSB, this was like the time of my life on Shellphish, we call it proing up, which is, you can see sort of the graphic where you go from noob to hacker to pro. So I definitely pro'd up in my time at UCSB. So even at MIT, I had like decent tooling, kind of had my stuff together. But here I actually took, God, probably like the first 3 months when I moved here, where my productivity was just zero because I spent time exploring other, sort of software engineering tools. So I now use i3 plus Terminator. So i3 is a tiled window manager for Linux. It's an absolute pain, I'll be honest. Like you have to program every single key on your keyboard. So if I want my volume buttons to work, I literally had to write, the raw commands to get the screen to lock and all that. It's a disaster. But once it works, I feel like I can move, infinitely faster. It more than pays the dividends for taking a couple weeks to learn it. For programming, I'm a big fan of the IntelliJ suite. So I switched over like PyCharm, CLion, all those, IDEs. Like if you don't use them, I was reading an article yesterday about like why people are still back on Vim and Emacs. I think that's fine for most programs, but if you're doing like really intensive, large projects, it's kind of irresponsible not to use, a really good IDE, in my opinion. Just the time you'll take setting up your Vim RC, you just download PyCharm and you get, right out of the gate, you get linting, you get testing built in. You can literally just hit a hotkey and run all your unit tests. It's it's like a must-have. I strongly advocate this to all of my employees. And in fact, we have like a tooling meeting where we all compare notes and figure out what our favorite tools are and then learn from each other. I got really good at writing law tech at UCSB. So Tech Shop on OSX was my tech editor of choice. And then that was my first exposure to GitLab, actually. I was kind of a GitHub snob before that. GitLab's better. It's objectively better. And mainly because their CI infrastructure is really good and really free. Like you can just write your GitLab YAML, throw it out there, and a runner somewhere in the cloud will pick it up, run it, and give you results. And then also for development, I got really good at like keeping my environments nice and segregated. So dir-env, I wish I would have had my whole career. This will let you set like environment variables based on the directory that you're in. And they also work in the subdirectories. So you could cd into one directory, it sets your Python path. You cd in a subdirectory below that, it keeps your Python path and will set like, say your LLVM directories or whatever you're working on. I mean, this is like a godsend for development, especially I was doing a lot of program analysis work where I have, multiple versions of LLVM. I can't imagine working without it, because then you would need, a Docker or a virtual machine or something. And then virtual env, I'm sure everyone's probably familiar with that one. That's, for Python, so that you're not constantly trashing your system-wide Python libraries or Python modules. So as a CTF player, this one's an interesting, take on software engineering. So I thought I was a pretty good hacker, but some of the guys I play with are just ridiculous. You learn so much though, like from just the standpoint of like computer science, CTFs, you have to learn everything there is to know about, PHP in like 2 hours to solve this challenge. And like MIT has this statement where, it's like drinking out of a fire hose. These CTFs are like drinking computer science from a fire hose, not just security, but like you have 1 weekend to pretty much learn everything there is to know about this system and then break it. So it's a lot more than just hacking. It really stresses your knowledge about how computers work. Like at the lowest level, you will like learn something pretty much every time. And then the software engineering, we actually had a big battle on our team. So they're like me and a couple other guys that would actually write classes and like use our imports properly. And then other people that just like from pwn import star, bam, just start ripping out commands. And they were way better than us. But, I still stick by my guns that like you should write your classes and do it properly. The reason they kind of owned us is because it's kind of speed over correctness, right? You get one right answer here, you win, versus a real world product. One right answer is not going to do it. You need to get the answer correct every time. So yeah, from pwn towards import star, if you're going to be a CTF player, but I better not see that in any production code. Actually, I'm very anti-import stars. The tooling that we use are like your typical hacking tools on our hacking teams, like IdaPro, Ghidra, Binary Ninja, Radare. The problem with all of these is sort of like, I think, the fundamental problem of software engineering, collaboration is a disaster. Like you're trying to reverse engineer the software with 20 other people or 10 other people and just synchronizing who's working on what. It is like the hardest problem in CTFs. And it's been like this sort of holy grail moment that like the team that figures out collaboration will be the best. And it typically goes that way every year. You see the team and then they'll release some tool that like, this was our collaboration tool. We use Git, Slack physical separation of teams. So this is more about how to coordinate people. That was really interesting. We found that if we'd actually physically separate each other, like you three in that corner work on this thing, you three work on that other thing. And then after that, CTF, all this stuff. My only other sort of commercial industrial experience of software engineering was I was an intern at IBM Research. I was actually an IBM PhD fellow, so I got to spend a summer with them at IBM Research, where I actually worked with Maria, who's in the class, and I think she's watching. So my big take here, this was interesting for me. So, IBM is massive. So my biggest takeaway was that big things move really slowly and have a lot of moving parts, right? I'm coming from this small, like hyper competitive research lab to a place that has more employees than my entire home state, I think. So the resources were incredible. Like that was insane. Like the IBM cloud, you could just go grab computers, like as many as you wanted. No one cared. There was no like billing involved. Your PI is just like, yeah, whatever. Insane coworkers. Like the internal knowledge there was out of this world. I met the guy that created the nipple on the keyboard. I don't know, it's called the little, red thing on the IBM ThinkPads. Like that guy works there, and I got to hang out with him. But then like the big things move slowly. It took them 3 months to get the hardware that I needed for my research and a 3-month internship, just because purchasing was, such a big deal. And even like the engineering process and things, you can just kind of see that there's some weight to it because it's in such a big system. So yeah, I mean, they obviously do software engineering. They do it really well. They invented the computer, kind of invented the field of software engineering. Fred Brooks, who actually founded my initial PhD program, they definitely know what they're doing. And from my point of view, my biggest thing was that everything I did there had to work when I got back to UCSB, because it was part of my PhD thesis. And there's no way it could be a one-off. So that code is very well written, very easy to open source. And literally I came back, was able to like, read the README, type a couple commands, and I was running experiments within a day. So the biggest thing I learned there was that apparently you can do software development on a Mac, although I wouldn't recommend it. I'm definitely, a Linux user, but they bought me a MacBook Pro. So I got Size Up. I paid for it to kind of mimic tiled window managers. The other thing I did over the summer that I wish I would have done earlier in my career was actually started doing Vim practice. So it's kind of puzzled me that it's taken me this long. So I was a college athlete to kind of correlate, I don't understand why sports are treated different than professions. So like in football, I practice all the time and I got really good at football. In computer science, I've never practiced, and that's puzzling. And having done practice, like I would literally run through Vim exercises, and it's insane. Like I probably am 20% more efficient at typing in an IDE now because I can just navigate quickly. So I would highly, highly recommend like practice. Don't always write code for the sake of doing something, but learn your IDEs. Like when it pops up with that little hint of the day, like read it. There's actually really useful stuff. It's going to make you faster, and faster is always going to be better, efficiency in software engineering, because you're just trying to get stuff out of your brain into the computer in the most efficient way possible. I also started using VS Code. VS Code's great. It's not for Python yet. I kind of wish it was, because it's a little more lightweight than PyCharm. But yeah, the way that IDEs are going, like I said, not using one seems irresponsible. And then I actually spent, all my evenings there reorganizing my Git repositories and getting all of my research code set up to become a company. So Kevin sort of alluded to this, so I'll give you a little intro to, what am I doing with all this knowledge and, all this stuff I've accumulated in my career. I launched a company last October. We incorporated, but we kind of officially started in July when I graduated and my two co-founders quit their jobs and we all started full time. Company's name is Allthenticate. So the idea, as you can see here, is we're going to give people more security and less burden. And the way that we do that is through a smartphone app. So we have an app that will let you unlock computers, unlock doors, log into websites, It has a private key on the app, and we sell this to corporations that their employees can now get in the office and go about their day without needing, anything to remember or anything to carry. This is actually our app on the phone here. The idea is that because it's on the phone, you have one credential for everything, and you can support any interface the phone works with. And because I was, the security background, it's resistant to any software-based attacks. So the way it works, the human is going to interact with their world. That stuff's going to reach out to the phone, and then the phone, handles the authentication and prompts the user as needed. So this slide is, I think, sort of the crux of what I mean by engineering and architecting good software. So the way that we have our code written is that we're actually down in the trusted hardware. So we have a way to interact with the user in a trusted way. We can use trusted execution environments like ARM Trust Zone. And then we store credentials in a secure element. And then on top of that, we have software where we can just sort of plug everything together like Lego pieces. So it doesn't matter if you're on a phone, if you're on if you're on an embedded system, if you're on a laptop, or if you're on a server, if you're running apps or web servers, all of this all fits together. So we have very nice API boundaries and sort of just very easy communication interactions. And below the dotted line, that stuff is secure. Above the dotted line, we don't care who writes it. So you can be a software engineer and know nothing about security, and we're fine. Like it won't compromise our system. Just to kind of show you what the app looks like, you would go sign up, verify your email, and then everything will pop up around you that you get to interact with. We also have like a web-based admin portal. I'll skip past that slide, but the whole point of showing you all this is that sort of the goal of this in the future is that we're going to be, sort of your go-to authentication protocol. So you'd use us just like you'd use Twitter. But I think the interesting thing about the company is we actually build every single thing. We design the PCBs in-house. Actually, I have that on the next slide. But we design our PCBs in-house. We design the mechanical design of our reader in-house. We design all the software for the reader, all the software for the phones, for the laptops, for the websites. It's like software engineering at its absolute apex. Like if this system is poorly engineered, we're going to fail. Like we're pretty much betting, and our investors are betting on me being able to architect and engineer a good system. So sort of my take on this after starting it is just like, wow, this is a lot of work. And you come into this really serious trade-off between moving quickly and doing it right. So it's really like I've pushed back really hard. We'll see how this plays out for the company on just getting it done to get it done. But I want to make sure that we build everything correctly from the ground up so that when we get to the point where we expand and hopefully have thousands of customers, that we don't have to rewrite our software. But like it was written well, it was architected well, and it's well engineered, well tested, that it will just work. It will scale, and we're not going to hit these crazy speed bumps in a year. It definitely feels more expensive than ever, though, to do good software engineering because there's actually a dollar amount on it. It's not like just my time, right? That is, 3 more days that we won't make revenue because we can't push that product out the door, for example. So yeah, it's really hard to not just lean in to do the hack job thing and write a bash script to get it to work. But I truly fundamentally believe that, we have to have a well-engineered system or we're going to get trounced by the competition. I mean, we're going up against like Googles of the world, who I assure you do very good software engineering. The other interesting thing this has taught me is that managing a company is way harder than managing a team. So, you probably worked with teams and classes or at your internships, and you can kind of manage that, like, we're going to build this product or this project, whatever you want to call it, and it has to work. But managing the whole company, there's a suite of products, right? Some of ours are hardware, some of them are software. Some of them are literally just like pamphlets and things that we put out, our mailing lists, like all of the different moving pieces. You're now taking all the techniques that I learned in software engineering and I'm actually applying them elsewhere. So like our sales cycle looks just like a Trello board. Our hiring process actually is a Trello board where like people apply, they go into Trello and we move them through the issues exactly like you would move through, a software project. So the skills definitely translate, and I don't think I would be as effective as a manager and CEO without those skills and knowing, sort of how to manage everything, track everybody's progress, and keep everybody synchronized. Like human synchronization, insanely hard. Give you a little insight into what we're working with. We have 5 distinct products. So we have the hardware, the Android app, the iPhone app, the software for the computer, and then the administrative portal that our admins can log into at our customers. We have over 40 GitLab repositories just in our company. We use Java, C++, Objective-C, Dart, JavaScript, CSS, SQL, Pythons 2 and 3. We're almost done with Python 2, like maybe 2 more months, and then we're done. And then tons of bash scripts, all of our install scripts and all that kind of deployment stuff. We have to cross-compile native libraries for iOS and Android. That's a disaster, but it works. I think that's honestly one of our like competitive advantages at this point, that we have a nice cross-compiling architecture. And then we support tons of different operating systems: OS X, Windows, Android, Chrome. We have a Chrome extension that we write. Just insane amount of software and projects that all link together. I tried to run like some command line programs to get you the number of lines of code that we have, but because of all of our submodules, it was kind of a mess. With submodules is like 1.7 million lines of Python code and like in the high hundreds of thousands for everything else. So for a young company, we actually have quite a bit of code that we manage. This is what I was saying earlier a little bit, so I won't go into this in too much detail, but the takeaway, if you think debugging software is hard, hardware debugging is just insane. Like we've blown up 2 or 3 boards. We had a couple of them where we had to do rework and like cut traces and fiddle things around. We had a customer whose door was unlocked for a week. That wasn't great, and we couldn't figure it out. That turned out to be like a weird software race condition thing interacting with the hardware. But yeah, it gets wild when you start playing with physical things. The management tools that we use here, these are all, in my opinion, kind of bike shed problems. Something to manage all of our software engineering. I used to think they were all equal, and then we found Notion. This has like changed our company. I love it. So Notion is effectively Trello plus a wiki. We use it for everything. All of our meetings, all of our milestones, our sprints, bug fixes, everything goes on Notion. GitLab, we use Slack internally, and then every video conferencing software under the sun, thanks to COVID. So I already went over those. We switched from Notion. I forgot to update this slide. GitLab, like I was saying, we use the free runners and we have some custom runners. So to build iOS, you actually need to do it on a Mac. So we host our own GitLab runners in here so that we can do builds and tests and actually like automatically deploy. We use Slack pretty much for sharing memes and coordinating lunches. We use G Suite. We have a ton of we have a full-blown hardware bench with the hardware test set up, and then tons of administrative software. It's actually really cool. Rippling, QuickBooks, HubSpot, those things are pretty nice. So I don't know if Wes saw my slides, or if you just could anticipate that this was going to be the conclusion of my talk, but like continuous integration, continuous deployment, it's insane. Like I can't imagine running a company without this stuff. So there's like deploy keys are epic. This lets us put actually like on our readers that we deploy, they get their own key, and in the field, they can actually pull updates from Git. So if we update our software, they can actually just pull the update live and like hot patch themselves. So we actually do tons of stuff with continuous deployment. All of our repos, if you merge to development, they will deploy to whatever the beta version is. You get the beta version of the app. We have like a staging stuff for all of our website, including our homepage. And then when we merge into master, it passes CI and bam, like it's live. So authenticate.net gets updated that way. Our admin portal, our apps, our readers, everything. It's all tied into our branches on GitLab, which makes managing it so much easier. Our website's hosted on Netlify. If you haven't hosted websites on a CMS, you're missing out. It's that same setup. It's like point and click, make my GitLab repo, a website, configure DNS. It handles like your HTTPS certs, everything. We also have linting in all of our CI. So we won't even like submit code if your spacing is off, or you use tabs instead of spaces, or you forgot to put a doc string. It'll actually fail CI. We use submodules like crazy. So we have, like I showed the Lego blocks, we have these security modules that are used in every single one of our products, and they're just imported to all of them locally as a submodule. So we have found bugs in them, and when we do, we patch it, and then every other submodule, patched. They all just pull into update on the submodule, and we don't have to worry about it, getting merge conflicts or anything across all the repos, or updating all the different repositories. And like I said, we have the branch dependent stages. So like testing runs on every branch, merges, we'll do builds, merge into dev, merge into master, we'll do deployments. So the typical day of a CEO, it's a pretty insane life. I'm not gonna lie. I would highly recommend it, but I can't imagine ever working this hard again, ever in my life. Like, I don't know if I physically could. Probably have a good like 5 years of this left in me before I either retire by choice or by physical demands. But I try to get 8 hours of sleep a day. I work out for at least an hour every morning. Honestly, like administrative stuff takes up most of my day, doing emails and talking to people. Engineering can go from like none to the whole day. And then eating is now just, a thing I do to sustain life, not really for enjoyment anymore. So lessons learned from, this kind of ridiculous career I've had and all these weird things I've done. The biggest one is just learn Git, like really, really learn Git. Don't just learn how to do a git commit -a-m and submit a thing. Even with the IDEs, I would recommend doing some command line stuff first until you understand what the IDE is doing. Like, figure out how to reset the head, figure out how to rebase a branch, get yourself into some nasty situations and then get yourself out of those to actually understand, when you're collaborating with people. This comes up way, way, way too much in our company. You'll get just crazy merge commits or merge conflicts and things that are going wrong. But if you're using Git really well, it's like easy breezy, and you just make sure you're always going forward. And do CI early and often. Don't wait until your project is like 5,000 lines of code and you have 15 different classes and all this crazy stuff. Because at that point, it's a pain to retrofit it. But if you're writing that like feature, right? You're adding a new feature and you write the test as you're writing the feature, it will actually make your code better. Because like more often than not, you'll be writing the CI and then you'll find a bug early on in your early logic. You're like, oh my God, this is hard to implement for this reason. The other thing, like I said, I don't know why it took me so long to figure out, but practice computer science. This is your career. This is your job. Learn the tools, learn the hotkeys, like get good at it. Don't just learn, the techniques and the theory of it of like, oh, I understand what an abstract class is, right? That's nice, but if you can't do it efficiently and you want to do it as a profession, you're going to struggle. And I was super slow my whole career. And looking back, I mean, the stuff I could have achieved would have been probably 10x, just because I would have been more efficient at transferring things into the computer. The other thing, not like software engineering related, but ergonomics is so important. like I refuse to work long-term on a laptop at this point in my life. Actually, like my hands hurt if I do it. I think from poor ergonomics or from playing sports my whole life, but either way, like I have a nice ergonomic keyboard, standing desks, like treat your body well. Don't destroy your body for your career. Like you get one. I'm 34 and like all my joints hurt. Don't do that, or do, but try to prevent it if you can. And invest in good equipment. So I strongly believe this at my company, and I've told my employees this many times. Like our equipment's cheap relatively to every other career. Don't let that hold you back from doing a good job. So if you're suffering trying to build things and it's taking you days when a new laptop would make it take hours, like invest in your career, or your employer, convince them to invest in your career and like get the equipment to do your job well. So I think this is the final thing I'll leave you with. I have a quote after this, but be nice to your colleagues and to the future you. Like this is really the goal of software engineering versus writing code. And there's a lot of instances that just because you can do it doesn't mean you should do it. So I use Python as an example because I've actually seen this a lot in my career, more so than other languages, where this function down here below will return a set of all subsets of its argument, but try to read that in one line as you're debugging someone's code and convince yourself that this is true, right? Like this takes a significant amount of mental effort to walk through the nested list comprehensions and the shift operation that's happening and an exponentiation to figure out, yeah, I believe it, right? So just because you can do something in one line, it's typically better to just break it out, put comments, have it be human readable, so that in 3 months when you come back or your colleague tries to debug your code, they're not stuck trying to solve some riddle. So like sort of my belief in most things in life, but especially with software, that anything worth doing is worth doing well. So if you're actually going to put time into building something, right, you should build something that people might actually use, even if that's yourself, you're building a project for yourself, and build in a way that they can actually use it if they wanted to. So don't just build a thing for no reason, because what was the point of that, right? Build it really well. Even if no one uses it, you learn how to build something really well. And then the next thing you build that people do use, they can use it. So in that, I'm happy to field questions. I was trying to watch the time. I think I did okay to give you guys time for questions, but my email's below. The link to my company is there as well if you're curious of what we're trying to do with all of this knowledge of mine. And yeah, I'm looking forward to what questions y'all might have.
All right.
Chad, thank you for your talk. I quite appreciate it. There were a number of comments from students comparing things you were saying to courses, offering help with, I3 if they had used it, but others hadn't, and a number of questions that we had students sort of hold for the end. So everyone is saying thank you to the chat, or to you now in the chat, but perhaps when that dies down, students who had questions could just retype them. Awesome. Kevin, I think I interrupted you. Was there something you were saying?
Yeah, no, that was the same thing. I can seed it because I remember. So one of the first questions that came up with was about software engineering preparation at the undergraduate level. So they wanted to know what your thoughts were, Chad, about whether or not like software engineering should be a separate major, or is it just that there's a shortcoming in software engineering education within computer science degrees? And if you had any thoughts about how people are educated or what should be a part of curriculum that you might suggest to students that are trying to start software engineering careers.
I don't think it needs to be a separate major, because it seems to me like a prerequisite for doing computer science well. Like unless you're a theoretical computer scientist, in which case you're in your own world anyway, and you probably don't write much software. But yeah, and it could have changed, right, since I was in school. So I'm actually not sure of modern computer science curriculum, but hiring some folks with degrees, it seems to have not changed radically. And I'm not sure what the proper thing is. I think like the emphasis on like short-term projects, right? I think it's just, there is no real need for, a week-long homework project to set up a Git repo and do, continuous integration and do all this testing. Like, by that time, you would have missed your deadline for your homework. So yeah, I mean, I would hope that there's just a software engineering course that becomes a requirement, I think, for the degree. I think would be the easiest. I think it's really needed. Like I felt like an idiot when I started my first job, and I'm like, why do I suck at this? Like I have like epic degrees, but I don't even know what Git is. How do I use this?
Excellent. All right, so then Dylan asks, what are your thoughts on work from home and how it affects software engineering productivity? I'm also curious about this and how you're dealing with it for Authenticate.
Yeah, so this one's really interesting. So our company is extremely small. There's 8 of us in a 2,100 square foot place. So we still come into work, but the perks of being a CEO is I get invited to like hang out with the big boys. So I was on like this CTO conference call with a lot of the big companies in town recently. And that I asked them that question. I was like, how do you guys deal without having whiteboards and being like physically near each other and, like whiteboarding out things to draw out like an architecture? And they kind of got a little bummed. And the guy's like, we don't. He's like, we have no answer. He's like, we meet once a week where we all have our own whiteboard in the office and like open up all the windows so that we can whiteboard things. So that part, as far as like defining the roadmap and sort of syncing brainwaves, I think is taking a big hit. The one thing it does seem to be doing well though, is like the use of like Trello cards and GitLab issues and actually like forcing people to tell you what they're doing. So there's actually this nice backlog of, everybody's status. Whereas if you're in the office, it's like, why would I update it on Notion? Because I already told Chad I'm doing this today, right? Like I don't need to move the card from pending to in progress. So I think you have to do better software engineering for sure, remote. I mean, the human element was the thing I was saying has been the hardest in synchronizing. But there's some aspects that I think are just do not yet have a solution to go remote. I have some apps I'm looking into on how to do whiteboarding and things remote, but it's definitely problematic from the high level view on how to create the high level architecture.
All right. Alexis asks, what are the key differences between working in the public versus private sector as it relates to computer science work?
So public being like IBM, private being, or public being academia?
So unclear from the question. I would imagine that this is more trying to compare, like, if MIT Lincoln Laboratory, technically private, but let's say receives a good chunk of funding from a government source, maybe that's public enough.
Gotcha. Yeah. Okay, so the biggest difference is profits, right? So like working at my company, we would, at this point, especially in our life, we would not build anything that does not directly turn into money. Like, because we can't, right? We can't afford it. We can't like do a fun thing for a year that doesn't play out. Whereas being at like a research institution, like IBM Research hired me for the summer to just like glitch hardware with no real intent of commercializing that, right? There's like, hey, this is something that would be interesting to know the answer to, and we would like to know. Kind of the same thing at Lincoln Laboratory. You kind of get this luxury because you're funded to do interesting things, not necessarily profitable things, that the projects you work on are very different. And actually the deadlines tend to be very different. And at Lincoln, the whole time I was there, I probably had like, I don't know, a handful, less than 50, like, oh my God, have to fix this today moments. We had 4 this week, like where like a customer would email us, and like yesterday I was getting ready to go to lunch and I get a customer text me. She's like, I'm locked out of my office and I have 2 meetings. Like, what do I do about this? Fortunately, it was her problem, not ours, but Yeah, I mean, I think the biggest thing is, and also the pressure on your code quality is way, way higher when there's profits on the line. So like at Lincoln, if I wrote poor code, it would normally get caught, but then it always had an excuse to like, it's just a prototype. Where now if I write poor code, people are like, I gave you money for this, right? Like, why doesn't it work? So the stress to like write good software is definitely higher.
Awesome. So I'll lump together a couple of these questions, which are basically asking like, how do you decide when it's good to invest time learning a tool? It seems like that was a big focus of your talk, was about, proing up. How do you decide when that's a good decision for you or for employees versus just getting something done?
I would say always yes to invest the time. I mean, if you feel that there's improvement to be made, do it. Like if you've worked with somebody and you were impressed by how quickly they could navigate, through their tooling, then you should try to get on that level. Yeah, I mean, I stress that pretty heavily with my employees. And there's one book I was reading, it was more about training your employees, so very closely related, but they were like putting it into man hours, right? And they're like, if you don't think that you have time to train your employees, they're like, say, you take 2 days and train your employees, and that saves all of those employees 20 hours over the year, right? They're like, the amount of total time you've saved your company and saved your employees is just, the payoffs are huge. And especially for you individually, long-term in your career, the time and stress you'll save yourself, it's something I really, really wish I would have done earlier. And honestly, I wish I would do more now, but I'm already like,
Oh, I may have lost Chad for a moment. I think you cut out for the last 5 seconds or so, Chad.
Oh, sorry. I said it's something I wish I still want to do now, is like kind of pro up even more. But since I'm transitioning out of a technical role, like my Vim wizardry is only to impress employees. It's not a good use of my time anymore, right? It's just like, wow, he actually does know his stuff, but I actually am writing like, less and less code every day.
All right. Let's see. Iran is asking, how did you come up with and evaluate your initial idea for the startup? Basically, how do you do research on the market to define and differentiate your idea from competitors while avoiding, like trampling on another company?
Yeah, so I've actually been tracking or like wanting to do this idea for about a decade. So for me, I just got to the point where I was fed up with it. I'm one of the top programs in computer security. I'm like, we have to be able to do better. At the time, it didn't seem like a thing you commercialize. It seemed like a thing you'd research. And then just throughout my PhD, I've just been tracking the industry. Like, what are they doing? I bought all the things. So I use Duo, I have a YubiKey. Every time Google pushed out an update, I played with it. And then it just got to the point where I'm like, if no one else is going to do it, I'm going to do it. And then we interviewed a ton of people. I mean, at this point, we're in the hundreds of just companies we sat down with and asked them, like, what do you think about the security of your company? What are you paying for? What do you like? What do you not like? And then started competing in startup competitions, got accepted to TechCrunch as a top pick this year, and then kind of got some confirmation from investors and companies in town that we think there's something to sell here.
Cool. Marco is asking, what kind of exercise do you do in the morning? So I guess asking about your daily routine, like basically, how do you find a routine to help you avoid burnout?
Yeah, I push that a lot as well. I think like, strong body makes a strong mind. So I allocate an hour every morning. I do, probably because I played football in college, I do weights 3 days a week, and then I'll do cardio 2 days a week. But yeah, just something to get you in a routine that you feel at least a little healthy, even if my diet, isn't the greatest in the startup life. Like I'll forget dinner some nights, but I'll go home at like 10 p.m. I have a peanut butter sandwich. And that's dinner. The one question I see here I want to answer, because I think it's really good, and I'm bummed I didn't follow my talk. Yaron says, what are the people you do have a daily sync up with? What kind of conflicts do you have to deal with? And what's the hardest kinds? So that's actually something we started off not doing daily stand-ups. That was a huge change. I love it. We do daily stand-ups for all the teams now. Like I said, not just the software teams, but even like the marketing and sales team. Like we stand up every morning and just like quickly sync. Like, what are you doing today? Do you need any help? And then what kind of conflicts do I have to deal with? God, I don't, like people are the only hard thing, right? Like, and not even that everyone, not that people are complicated, but timelines. Like, and I gave a lecture to our company about this a couple weeks back of like figuring out when you get to the point where you can set a deadline and consistently hit that deadline, you help everybody. Like, you'll be less stressed. Other people can rely on you, but time management is just hard. And then time managing other people's time management is the hardest. Like, you take their guesses and have to plan, strategies based on their guesses.
Cool. Somebody, was it Ollie? You have a hand up. I guess you can unmute to ask your question.
Yeah, sure. First of all, thank you for the lecture today. It was really informative. I really found it really intriguing as well. I wanted to ask about so most of us here are aspiring to be software engineers, I'm assuming. But I wanted to ask, after we graduate, what are some advice you can give us to do after we set out in the job market, the current job market, and what are some things what are some misconceptions that people have about software engineering, and what are some surprises you had as you went into career and into industry?
Some misconceptions that I had. Honestly, I've been very pleasantly surprised. I haven't had too many moments where I was like, oh, I expected more, but that could just be my personality where I'm always, I don't know, kind of like a puppy at times. It's excited to be here. Do you have a specific thing that you're worried about?
One thing I'm worried about is that sometimes people tell me that the trajectory of your career is not always going to be always writing code. Sometimes you have to maybe you have to do administrative stuff, like you said. Sometimes you have to do planning. Maybe you have to do other things you're assigned to. It's not always what you expect. You're not going to be coding most of your time, which is what I was thinking I was going to do when I was getting into computer science. But now I'm hearing that might not be the case. So,
yeah, that's actually a great question. I used to have in my slides what my time allocation was at each phase of my life, but I took it out this time around. But that's very true. So when I was at MIT especially, I became an expert PowerPoint engineer. So there's kind of this phenomenon that will happen at any company where you'll do really good work, and then they want you to talk about that really good work a lot. And then when you talk about the really good work, they figure out you're good at talking about good work, and then they want you to talk about even other people's work. And then, yeah, you will certainly be doing way more presentations than you think you will be now. That's kind of the perk of academia and grad school, actually. That was my biggest relief when I switched back, is that I didn't have to do any PowerPoints unless I got a conference once or twice a year. I was like, oh my God, I get to do, engineering every day. That was a relief. And then now in my role, yeah, I mean, I wish I got to program more. I definitely miss it, but I think that's a pretty valid concern, that you probably won't be programming 24/7.
All right. Let's see. So a few other questions have popped up. Does Authenticate use Authenticate internally?
Of course we do. Yeah, so we use it on our laptops and our doors right now. By January, we'll hopefully be using it to log into G Suite and all of those things. We're kind of building out our integrations. But yeah, at our old office, we actually didn't even have a front door key. So that was our only way to get in the office. We went all in on it.
All right. Student is asking, how do you convince customers that your program is secure? I guess more generally, how do you convince customers that what you have to give them is worth paying for?
Those are two different questions. The first one is actually funny that I thought they would care about the security part, right? So we architect the whole system so they could host their own server and nothing leaves their infrastructure and all these great security features you'd want. And resoundingly, the response I got was, we don't care. They're like, you have a doctorate in computer science from one of the top programs. Like, we trust you. I'm like, but don't you want to look like that? We don't care. Like, who else would we trust? We don't trust you. To convince them to use our product, that one, I mean, to be completely honest, we're still in the very young phases. So that one's tough. I mean, we don't have the clout of like, a Cisco or these large companies. And for the bigger enterprises, there's been a large concern. They're like, we don't even know if you'll exist next year, right? Like, even if it is secure, they're more concerned about just the youth of the company. So most of our initial customers have been smaller companies that are fine with that risk.
All right. Is there any other question here?
There was there was that, as a CEO, do you think your computer science background helps you manage your company?
This one I do, actually. And I kind of spoke about it a little bit. Like the way that how do I phrase this? Like, we're architecting our sales based on sort of like the way that you'd software engineer, right? So we go through our sales process the same way that you would move a software engineering card through the process. And actually our hiring process is based on a couple sort of algorithms from math. So like the optimal stopping algorithm, I employ that in our hiring process. So like the secretary problem, and then a little bit of psychology. It's called satisficing, where like, you're not supposed to always go for the optimal solution. So there's some mathematical theories about that too, but like, you should get to just good enough and then be happy there, because any time invested past that, and tons of scheduling algorithms come up in running a company that having the computer science background, then it's like, this is solved. Like, why are we even talking about this? Because like, you can schedule this and get the optimal outcome. So let's just do that. So I do think there's some help, and just like the way you think about problems and the way that you can break them down and solve them. But knowing that the hiring problem is solved helps a lot. And I actually had to explain that to the one guy that we rejected. Well, we actually never interviewed him, and he got very upset about it. And I explained our whole hiring process. I'm like, look, it's based on the optimal stopping problem. We interviewed the first third. We had one that was better than the first third. And at that point, we're done. Like, we don't have time to invest. We're a small company. So for sure, we use it. Whether or not it helps, I guess, is yet to be seen. But I think it relieves some stress off of me, sort of having some more concrete grounding to the decisions I made. It's not, I felt that way. There's some theoretical backing to them.
Cool. Sam is asking, what is your take on grad school first versus going right into industry with a bachelor's degree?
That's interesting. If I could do it again, okay, coming back to the PhD after industry was great for two reasons. One, I was really good at what I was doing at the time, whereas going straight from an undergrad, I felt a little bit lost and didn't exactly know what was going on. The other one is it relieved a lot of stress, because dropping out of grad school or failing out or whatever, the first time was just like, oh my God, this would be the worst thing that ever happened to me. And when I did drop out, I felt terrible. But then knowing that you can get really cool careers in industry and you'd be happy there, and it just like, I enjoyed it way more the second time around, just knowing like I came in, I knew my stuff. I didn't have to take a year to just figure out how to write good code and that stuff. But knowing that if this doesn't work, the backup plan is fine. And knowing what the backup plan was. That being said, it's really hard to quit your job and go back to grad school. So if you want to go to grad school, especially in our fields with the paychecks that they're handing out, you might want to just get it done. Because that was one of the hardest decisions I ever made in my life, was giving up my paycheck to come back and finish the doctorate. That was not easy.
I sympathize. Let's see. Annie is asking a pertinent question. What do you think about technical interviews and hiring practices for finding good software engineers?
It's tough. So I've interviewed for most of the top companies that you can think of, and I have my opinions of them and their interviewing process. But coming up with an interview process that's going to get you the right person is complicated. So far, I think I've just been more lucky than smart, but hopefully I can eventually figure out how I got so lucky with my initial hires and smooth out that algorithm. I personally don't think that having people write code on whiteboards teaches you anything. I don't know what I could glean from that. I've been asked to do that a lot. You'll probably be asked to do that a lot. It's a bummer. I, I don't think it's a good hiring mechanism. Our interviews here, I tend to pick problems that we actually solve internally or want to solve internally, so I can kind of gauge technical competency and interest simultaneously. Um, I've seen that at a couple other companies I've interviewed with where their interview questions were pretty guided towards the job I was interviewing for. Yeah, and I don't think you should have to practice for them. Like Google sent me a study guide and I was kind of confused. It doesn't seem like an interview should be something I could practice and do better over a weekend. Like you should be hiring the human, not the weekend of learning. But yeah, I guess those are kind of my takes. I feel like we go offline. I could really dig in deeply onto what I think of other people's hiring practices. But yeah, ours we do 30-minute interviews and then follow-ups if needed, just for efficiency reasons. And actually for internships, we dropped it to 15 minutes.
I see. All right. We're almost got maybe a minute left. Um, what went into your decision for founding a new company instead of the safety of working at an established company?
I think the challenge, honestly, and it's one of those things where like I think this should exist. I think it's better for the world if we actually use good security protocols and get away from passwords and kind of lock things down a bit. So there's a little bit of wanting to leave my mark on the world and wanting to try something really, really, really hard. Definitely found that challenge. Without a doubt, this is the hardest thing I've ever done. So, I appreciate it. I'm glad I did it. If I wasn't in computer security with the degree I have in my resume, I think it would be tougher. If my backup plan wasn't go get a lucrative job somewhere, I think I would have thought more about it. But yeah, I mean, I think it's to try and do something really, really hard and see if I can succeed at it. It was kind of the difference. It's like I'm pretty confident I could work at Google and be a good employee, but who knows if you could be a good CEO, right? I mean, that's up in the air.
All right, excellent. Well, then we are about out of time. So I'll thank you again very much, Chad, for another great talk. I will stop the